Good morning, everyone, and thanks for joining us today. I'd like to start by acknowledging that we are speaking to you from the city of Vernon, which is on the unceded territory of the Silks Okanagan people, the original inhabitants of this land. You have joined part 2 of our 3-part series on getting your project around water to shovel ready. My name is Marta Green, and I'm a senior hydrogeologist in the BC and Yukon division here at Associated. And like last time, I'll be the facilitator for this session. And an update on my backyard egg-laying chickens. So last week, I was a little bit frustrated because they were 18 weeks old and they hadn't laid any eggs yet. And sure enough, they laid an egg within 24 hours of you guys being here. So thanks for that. So a recap on our Getting to Shovel Ready webinar series so far. So the first part was with Heather Taylor last week on the specific regulations and permits required for construction around water. And if you haven't checked it out already, that session is now posted on our parent company's YouTube channel. Just search for Associated Engineering on YouTube. The link is also on our website on the same registration page link that you all have. For today's session, part 2, we will have Carrie Nadeau talking about some treatments you can make instead of your typical riprap or concrete reservoirs for erosion control and stormwater management near streams. So pretty cool stuff there to help hit those flood and drought ready targets. And last but not least will be Drew Layback, senior hydrologist based in our Kelowna office. And the first 2 sessions are more locally focused around a planned construction site or a utility like a stormwater system located near a watercourse. But for those of you that have a bit more time and are involved in more the long-term planning stage right now, let's say you're planning a water withdrawal or the province has asked for an environmental flow needs assessment as part of your water license application, Drew will shed some light on the mystic world of EFNs. So please join myself and Drew next Tuesday, June 23rd for our last session in our series. So before I introduce Carrie, I'll just go over the agenda for today. And we'd like this webinar to be as valuable experience as possible for all. So we'll have a 20-minute presentation by our subject matter expert, followed by a 20-minute Q&A session. To help moderate the Q&A portion this week, same as last week, we have the very talented Melanie Puretsky, a senior ecologist in our Vernon office. As well, say hi, thanks. As well, backed by popular demand, we have Heather Taylor, our presenter from part 1, here to answer the regulatory related questions. Thanks, Heather. Heather is an aquatic biologist and associated species regulatory specialist. So welcome, Mel and Heather. So without further ado, let me introduce the very talented Carrie Nadeau. She's a biologist with a passion for restoration. Her background in fisheries and vegetation ecology is woven into riparian and wetland restoration projects. She plans and implements municipal and provincial projects, including grant-funded work and policy review. Her efforts help to create a climate resilient and improved landscape. Carrie is currently president of the Columbia Mountain Institute of Applied Ecology, a volunteer position where she collaborates with fellow ecology enthusiasts. So thank you for joining us here today, Heather. Carrie. Sorry about that. So without further ado, I'll pass it on to you, Carrie.
Thanks, Marta. Thanks for introducing all of us. Hello, good morning, everybody. Today, it's our part 2, and I'll be talking about erosion control and stormwater management. The 4 topics I'd like to hit today, briefly, the first one is just to talk about the importance of wetlands and riparian areas on our landscape. And then I'll go into kind of the meat of our presentation, which is water management and constructive wetlands as a solution. One solution. I'll be going through, site selection, planning, and sort of your design considerations for wetlands. And then we'll go on to erosion and sediment control solutions, bioengineering as a solution specifically today. And again, going through the same thing. Is your site suitable? Your planning and your design considerations. The last piece of my presentation, we'll be going through legislation that applies to these projects, BC in particular, and some of the available grant sources that are around. So just a quick touch on climate change. We've all been experiencing our, increased storm events, frequent storm events that are really intense. I know Calgary experienced some crazy hail in the northeast of Calgary recently. Here in the Okanagan, we experienced a really crazy storm just last weekend, I think it was. And so we're really thinking about how we can make our communities resilient to these climate change. What can we do to adapt to climate change? What things can we do to mitigate for climate change impacts? And how can we build a resilient community? So when I think of climate change and building resilience in our community and the infrastructure for our community, I think of watersheds. And so specifically watershed health. How healthy your watershed is will relate to how resilient your community will be to climate change impacts. So here we have our little, water cycle diagram that everyone's familiar with. And so when we start interrupting the cycles of this water cycle, so we start breaking up the pieces, some things start become broken. So when we build roads and our infrastructure, we increase surface water runoff. That's what we call stormwater. And that stormwater would have normally have gone right into the ground where it hits the ground. Instead, we're causing breaks in the system where the water can't actually get absorbed into the system. So the solutions that we're going to talk about today are increasing the health of our current watershed. Wetlands provide ecosystem services such as holding water, back flood attenuation, recharging groundwater systems and surface water systems. Riparian areas slow the flow of surface water. They help with erosion and sediment control along our waterways. And so we're really talking about watershed ecosystems as a whole, what sort of services we need to repair in order to increase the resilience of our watershed and our infrastructure systems. So into constructed wetlands. I've been working with the Okanagan Basin Water Board for the last couple of years with a lot of other authors and partners to create a constructed wetlands stormwater management guidebook. This is specifically for the Okanagan, but there's a lot of pieces of this guidebook that are applicable to everybody, all regions of sort of North America. And so there is a link on this page here. You can go check out the whole big booklet if you like. I'm going to talk about it briefly, the key components of this guidebook today. So here's an example of what a constructed wetland could look. It's very artistic, of course. You have separate components, but really what I want you to pay attention to here is that we have sort of an inlet component that absorbs your sediment and all the initial things that are coming into your wetland. It's able to be maintained, and you're keeping the sediment out of your actual sort of treatment wetland, which is the center wetland. And so that wetland's really focused on what you're trying to treat for your water quality. And then the last little piece is a wetland is a habitat wetland that's really focused on creating habitat for wildlife. And so you have these separate objectives and goals, and each thing is separate. So constructed wetlands, what are they and how do they work? So I'm showing here two examples of a constructed wetland configuration. So the top sketch here is a subsurface flow constructed wetland, and where the water actually comes into your wetland and flows through a very low permeable soil on the bottom. And the roots and the microbes in that soil are actually what starts to biologically break down your components and your pollutants. And then the water flows out the other end. In the bottom, we have our surface flow wetland, which is where the water comes in and the water actually flows along the surface of the plants. That green scummy buildup that you see in wetlands, that's full of microbes, these wonderful little biological things that degrade and break down through aerobic and anaerobic processes that get rid of your pollutants. And produce, cleaner, better water at the end of your outlet of your wetland. So when you're thinking about constructed wetlands, you really have to think about first your goals, your objectives, and your priorities of what you're trying to do here. So the ecosystem services that wetlands provide is, water quality treatment. They really, really help with taking all our sediments out, treating that water quality or treating that water so that the quality at the end is better. So you need to decide what type of things are you trying to treat in your specific situation. Is it hydrocarbons? Maybe it's really high nutrient sources off of agricultural lands, or if it's really stormwater and you're really worried about hydrocarbons coming off of roads and parking lots. So you really need to key out what is your key goals for your treatment. Flood attenuation, flow attenuation. Maybe your systems are becoming overwhelmed by high storm events, and so you really want to have an area where you can capture the flow of that water and hold it there so that you're not overwhelming your stormwater systems in your cities. And so that really increases the resiliency of your existing systems. Habitat creation and biodiversity. Maybe wetland habitat is a big key thing for you and your community in this specific spot. And then amenities in your landscape. Maybe there's indigenous values that you want to highlight. Or you're creating a big subdivision and you'd like to have a nice big pond in the middle for people to walk and recreation, or there's education opportunities. So out of all of these things, you really need to nail down what are your priorities for treatment first, and then the rest of the priorities fall into line after that. So how do we know if our site is suitable for a constructed wetland? So you've gone through your first step here, which is establishing your priorities for your water treatment for your specific treatment wetland. Then you need to evaluate your receiving environment. And your receiving environment takes into account, is the outflow of your wetland, is it flowing into another watershed or a different system? Is there fish there? What type of wildlife are around? What topography do you have? Where's your groundwater table? Do you have a shallow groundwater aquifer? All these things you need to evaluate to make sure that you're incorporating this into your design. Your third step is to first cut your estimate of your land that you need, your hydraulic retention time. So these microbes really need time to break down these pollutants. So they require the water to move slowly. So you can calculate that. And from that, then you can calculate the area that you need to create the flow and the time that you need from that. So once you know the area that you need and you've found a site that's suitable to your constructed wetland, you can incorporate your design. And so these design components here are the typical design components that you need to incorporate into your constructed wetland. It's really important to have a sediment forebase, your inlet zone, and your pretreatment zone if you have a lot of hydrocarbons. Your sediment forebay really absorbs all the sediment that's coming into your wetland. You want to have that as a maintenance, very sort of hard engineering structure. You don't really want to have wildlife habitat in there because it does require maintenance, and you want to avoid impacting any wildlife or avoid permitting in the future. Then you have your constructed wetland cell, and then your outlet structure. Also, again, with your outlet structure, you want to make sure that you can maintain access to that structure and that it doesn't create wildlife habitat in the meantime. Habitat considerations, of course, there's lots of plants that live in different zones of each wetland, and so you need to make sure that the plants that you're using to plant in your constructed cell are adapted to the water levels and the water conditions that you're building your wetland to treat. So going on to bioengineering, erosion and sediment. Erosion is always a big problem in areas that have been disturbed or degraded. Sediment is a problem as it gets introduced into our systems, and it creates all sorts of problems for fish and infrastructure. So bioengineering can be a solution to that. Building resilience is restoring our riparian ecosystems to build resilience in our systems so that we can absorb and slow the flow of water and decrease our sediment and decrease our sediment introduction into our systems. So soil bioengineering, what is it? It is the use of living plants to perform an engineering function. And so when I say an engineering function, here we're talking about slopes that are unstable, that are being eroded either by creeks or shallow surface water flow. In the Okanagan here, it's quite dry, and so these living plant systems do require water, so we generally restrict our bioengineering sites to around creeks and streams and lakes. Anywhere else in BC where it's wetter, the coast, the north, Alberta, most of Canada is wetter than the Okanagan, and so you can apply these techniques to a wide variety of slopes that aren't necessarily integrated right into a stream interface. So we use willows and poplars and dogwood. These are the species that can grow from stem cuttings. So what we do is we cut off branches and we stick them in the dirt. To a really deep depth, and they grow. The root systems knit together to really stabilize the soil. And so each specific prescription, we orient the stakes in a certain way so that their roots really connect together and stabilize that soil. They also grow really fast, so they soak up a lot of water. So if you have a really soppy, wet site that's slumping because of all the wetness, these species really soak up water really fast and help stabilize your soils that way. If they get disturbed or part of them gets blown out in the future by a flood or something that's happened with a high storm event, they are generally self-healing. The roots grow back, they grow new shoots, and everything becomes denser and lusher with disturbance. I mentioned the roots, so they actually root along the entire length of the cutting, and so each little leaf node produces roots instead of shoots when you plant these, and so that you have a meter depth of roots that really strengthen your soil. So is your site suitable? How do we know if bioengineering is an application for your site? Well, first we need to evaluate the causes of your slope instability. What is causing this problem? You have signs of erosion on your site. What type of erosion is it? What type of process is happening to cause this erosion? And then we can evaluate what type of bioengineering techniques that we can install in order to address this erosion process and take that problem out of the picture. We can treat that problem. We also need to characterize the soil on your site and your site slope. And so highly unstable soils are, gravels and sands. If you have clay layers interspersed with other soil layers, those can really cause slumping and slide other soils off that aren't as stable as clay. Clay is very slippy, obviously. And also your slope. So if you're really unsure, geotechnical engineers can really help you determine what sort of slope is appropriate for your soil type. And that'll help you determine if what sort of slope grade you need to attain before you install your bioengineering applications. There are site restrictions as well. Do you have infrastructure that's within your slope that you can't create that type of slope that you need? Are there large buildings at the top of your slope or roads or some sort of, something that would cause pressure on the slope to cause it to slump as well? So we need to consider safety and what sort of infrastructure is there. Design considerations. So if we've decided bioengineering is an appropriate treatment for our site, then we can move forward with our specific bioengineering design. You need to consider how much local material is around. So do you have a source of cottonwoods or willows that's close? It's live living plant material. So you need to have a close source to your site for it to be a viable treatment. We do plant these stakes when they're dormant, so early spring or late fall. We don't want to plant them when they have leaves on, because then those little leaf nodes, you plant them in the ground, they don't want to grow roots. They've already started growing shoots. So we want that hormonal shift to go growing roots when they come out of dormancy. Costs usually compared to engineering design are cheaper. It does, of course, depend on your site and your treatment. The larger the site and the more engineering complexity, generally bioengineering is much cheaper, but it's sort of a site-dependent thing. Because you're restoring an area, there is a lot more grant funding that's available for these types of projects because you're essentially replanting the riparian area and stabilizing slopes. You're improving fish habitat because you're decreasing sediment introduction into your waterways. The regulatory requirements are generally simpler. Compensation is not required because you're restoring, but I'll get more into regulatory points later. Here's an example of what a sort of design looks like for a bioengineering site. First, you can see, I'll use my pointer here. You can see these little bubbles here. So I've been to the site, I've characterized what type of erosion processes are happening, site specifics, site limitations. Then I've gone ahead and mapped out what sort of treatments I want to treat in each area. So we have two different treatments here. We have in the purple is just a live staking. So that's, the big, huge stakes that you plant 1 meter into the ground, spaced a certain amount apart. And then over here, we have our design specs for dense live staking, which is really, really dense stakes put together at the bottom of a stream to really slow that flow of water and reduce the undercutting erosion that was happening at this site. Every design spec I do is specific to each site. And so it's really important to tailor your bioengineering treatments based on your site specifics, your site assessment, and your site limitations. So here's an example of a slope at a reservoir. The slope was above a drinking reservoir. It was really saturated. The property above was totally cleared, so a lot more water introduction. We peppered it with stakes, a bunch of different treatments, but we planted it in May, and in June it's fully flushed out of the same year. Here's another different type. It's called wattle fencing. If you have a really steep slope and you don't have the opportunity to lessen that slope, you can install wattle fences. They're kind of like little tiers. All of those stakes will grow. This is installed in May. And again, it's growing in August. So same season, those roots really grow and you have slope stability just about instantly. Great, well, on to permitting and grant sources. So in BC, our BC legislation, we have the Water Sustainability Act, the Wildlife Act, the Riparian Areas Protection Regulation, or RAPR. And then federally, we have Fisheries Act, the Migratory Birds Convention Act, and the Species at Risk Act. This is general. There are more acts out there that could apply to your site, but just generally today, if you're working in or around water or what's been designated as a stream in BC, which does include natural native habitat wetlands, you will trigger a Section 11 permit. A notification or an approval might be required. If you're constructing a constructed wetland that is in a place that there is no previous water, then you do not require a permit. But if you're going to be connecting it to fish-bearing water, or you're constructing it in conjunction with something that's designated as a stream, you will need to obtain a permit. Bioengineering applications, generally, if there's erosion happening at your slope at the base, if it's creek erosion, then you'll generally be installing stakes below the high water mark, which is where this act is triggered. Then you will require a permit. Depending on your site and the stream characteristics, you may require a notification or an approval. It's a bit of a gray area. You have to kind of talk with your regulatory agency and determine what's required. Wildlife Act is required if you're going to be potentially impacting wildlife, or you need a wildlife salvage. Turtles and amphibians hibernate, and they also breed, so you need to be aware of what season you're constructing in to avoid impacting wildlife. If you're within 30 meters of a stream in an area that is covered under the wrapper, then you're going to need to do an assessment and submit to the province and coordinate with your municipality. Most soil disturbance triggers FRAPR, and so if you're digging a wetland or doing bioengineering, that is soil disturbance generally. Federal Fisheries Act, of course, we can't cause any harm to fish, so you need to make sure you're not introducing any sediment or disturbing any fish habitat. Migratory Birds Convention Act, if you're doing any vegetation clearing, there's a breeding bird window that you need to avoid so you're not disturbing breeding birds. And of course, if you're on federal lands or in critical habitat areas for species at risk, you will trigger the Species at Risk Act. Some grant sources that we have. Just quick key grant sources. I encourage you to go on the Canadian Environmental Grant Makers Network, the top bullet here on their website. It's a search engine for environmental grants. You can type in what sort of filters you want to put in there to see if there's any grants that apply to your project specifically. It's a great tool. It doesn't have all of the grants in there, but it really is a good place to start. I would encourage you not to put too many filters into your search engine at first, because it does tend to be quite specific in its filter. It's not perfect. You may sort of filter out all of the grants, and you may miss some that could be applicable to your project. Environment and Climate Change Canada, they do have quite a bit of funding pots. You really need to drill down into each one to see when their application time is open. Generally, they do have an application opening every November and every February, but you really kind of have to keep on top of that and figure out what timeline works for you. Habitat Conservation Trust Fund. I know there's an intake this November. You can apply for up to 5 years of funding. It does require in-kind and other types of requirements in order to be eligible for funding. And so all of these fundings have different eligibilities. Maybe only municipalities are eligible, but a lot of them are communities, societies, nonprofits, Indigenous groups, municipalities. And so teaming up with different partners is really a great way to ensure success for grant funding applications. So with that, there's a lot of grant funding available. You need to sort of scroll through what's applicable for your project. And that's the end of my talk. I think we are on to our question and answer period. And so I will hand this over to Marta. Thanks for listening, and I'd be happy to answer the questions that you have.
Thanks, Carrie. Very informative and inspiring talk, and I just love the idea of having multi-purpose projects. So not just solving an engineering problem, but also basically increasing all of our amenities, access to wildlife, improved water quality, more green space, and yeah, I think that's so great, and I think it would be easier sell to mayor and council if you had those multi-purpose projects. Thanks. So now we will start the Q&A. So Melanie, do you want to take a question from perhaps during the registration period? Start
Sure.
there.
There's a couple questions. There were a few questions during registration that I believe Carrie answered during her presentation, but one that I think would be interesting for everyone to hear is related to managing a stormwater pond and dredging or other maintenance operations. How would you manage that as far as permitting?
Great, thanks, Mel. Good question. So the permitting requirements, you're right. I have been involved or have knowledge of other constructed wetlands that have run into problems with permitting because they haven't been able to construct a sediment forebay. And so when you're really considering your design for your constructed wetland, you need to have that sediment forebay that's separate from your constructed wetland cells, that keeps out wildlife, and that you're able to come in and maintain that, dredge it, and make sure that it's functioning the way that you need it to, so that you can avoid actually having to dredge in your constructed wetland area, because that causes problems with the plants that are in the microbes that are filtering out your pollutants. So a Section 11 notification or approval might be required if your constructed wetland has started to naturalize and wildlife has started to move in. So you'll need to salvage your wildlife under the Wildlife Act. You'll need to get a permit, and then also a Section 11 notification or approval. I don't know if Heather has anything to add.
Yeah, I will just say that it does depend, again, as Carrie pointed out, on the connectivity to any existing watercourses or streams or groundwater. We did have a project where there was a water license required because it was actually groundwater flow intercepted into the wetland. Another possibility too is that if you do need a water license for construction, those licenses often incorporate maintenance into them, so you might not have to do a new application every time you need to dredge. You might have that covered in your water license if the water license was applicable from the get-go for permitting.
Thanks, Heather.
Okay. Sticking with the wetland theme, I'll ask one more from registration. Compensation. What might it look like if you were proposing a stormwater management pond and also hoping to have some compensation for wetland loss?
Yeah, good question. So if you're doing a project that has impacted a wetland and you're required to compensate for those impacts under the Fisheries Act or provincially, you're required to compensate. Generally, it depends on what sort of requirements are enforced by the legislation and what you've impacted. So if you've impacted a certain type of habitat, you're usually required to replace the same habitat or a better quality habitat. And so if that stormwater wetland can hit those points with the habitat that you were impacting, then some of it could be available for compensation, but you'd really have to consider what type of habitat you're creating with your stormwater wetland versus what a normal habitat wetland would create. You can always add a habitat wetland on the outlet of your stormwater wetland, and that might be a way to hit those targets as well.
Great. Okay, I'm going to jump to a bioengineering related one. This is from Graham Watt. What are the constraints on using vegetated riprap in a high shear environment? And could bioengineering be used above the SEL to provide habitat or cover the riprap itself?
Above the SEL.
FCL, sorry.
Flood control level?
Flood control level, okay. Yes, it depends. So if your site is a very wet site and it would support installation of live materials at the top of the riprap, if there's enough water available there for them to grow. A lot of problem I see with bioengineering application is that the stakes aren't installed in a location that has enough water to support them, or they're installed too shallow so they dry out and then they fail. So a really common failure with bioengineering is that it's just too dry and then it requires a lot of watering maintenance. So when you're designing your site using live materials, you really have to consider what water availability you have. Yeah, high shear stress environments, it depends on the risk of the site if you want to use bioengineering versus engineering. And I would work with an engineer on those types of sites in order to assess what level of risk we're comfortable with, risk of slope failure, to be able to move forward with what type of bioengineering design we want, or if it's appropriate.
And I guess to add to that, I think you said in your presentation, depends what your amenities or your infrastructure are that you're trying to protect. If it's a bank that's well away from infrastructure, then there's less of a risk from that perspective. Yeah.
Yeah, exactly.
Okay, there was one just kind of related to wetlands. Is it common for constructed wetlands to become occupied by beavers?
It depends, I guess, on your site. If you're worried about beavers, then you may want to construct a constructed wetland that has subsurface flow. So then you're getting your treatment requirements, or you're hitting your treatment priorities with the subsurface flow wetlands, so beavers aren't attracted to come and try to dam up your wetland and make things slower. Yeah, outlet structures are very tricky if you have a lot of beavers in the area, because it's just the perfect creation of a habitat where they can plug up that outlet structure really easily and create a wonderful habitat for themselves. So a subsurface flow wetland might be an answer to that. There are different trash racks and things that you can install around your outlet structures to discourage beavers as well. But that definitely, to be successful, yes, beavers need to be considered in your design for sure.
Okay, and then related question, do you have some examples of exclusion structures or methods of excluding wildlife?
Yeah, there's fencing we've used, and it depends what type of wildlife. Here, painted turtles, the fencing has to be really secured in under the ground so they can't get underneath. Lining your constructed wetlands so that there aren't substrates for them to hibernate in, so not creating good hibernation conditions. Trying to think of what other habitat. Beavers, we do use fencing as well, because a lot of times they'll come and take our bioengineering stakes from us because they're perfect for dams. They're sharpened at one end even, so like the best scenario. So beaver fencing is a really good idea as well if beavers are in the area for bioengineering.
Okay, I think that we covered most of the main ones. Yep, just a few thank yous. And then if we missed some, there were a few earlier that I was just seeking clarification on the question. We'll follow up with some answers after this is done.
Great.
So if you have any burning questions, send them our way right now. We can have time for a couple more. Were there any, Heather, that you wanted to answer that we ran out of time on from last week?
We did get a question about a list of regulations that apply, federal and provincial, for working in and around water and riparian areas. And so, certainly not a comprehensive list, but definitely a good place to start for provincial regulations here in BC specifically, although there'll be similar legislation in all of the other provinces. The Water Sustainability Act applies, so for both surface and groundwater. The Riparian Areas Protection Regulation applies to any work within 30 meters of any watercourse. Notification of an environmental assessment office may be triggered if the project involves pumping groundwater at a rate of 63.75 liters per second or more. And then federal regulations, the Fisheries Act and the Navigable Waters Act are the two that generally apply. And then the other thing to look at is the local government regulations. The bylaws and development permits are often triggered for work in sensitive areas, which often include work around streams. That'll definitely get you through the process. There's a lot of information online through the Government of BC and the Fisheries and Oceans website too that you can reference. That's a big one, I think, that's relevant to this particular webinar. Just a little bit of an expansion too. We did have a question last week about when the Riparian Areas Protection Regulation applies. I mentioned it applies pretty much to any shovel in the ground, and somebody did ask about maintaining existing disturbance. And so there are provisions in place that allow routine maintenance of an area of human disturbance, buildings or structures, etc., under the Riparian Areas Protection Regulation. So, lawn trimming is allowed, snow removal is allowed. You can't cut down any trees or shrubs, but you can definitely trim them if you need to trim branches. You can do that. The one thing to note is just important that the maintenance doesn't lead to any deleterious materials being introduced into the nearby stream. So, you know, snow on roadways often has contaminants in it. So you want to make sure that if you're removing snow that you're not putting it in a place where it's going to directly melt and flow into a stream if it has high salt content or any metals content that can't actually go directly into the stream. So it's just a few things to consider there. I think those are probably the most relevant to this particular webinar from last week that we didn't get to, Marta. Mel, are there any other questions from today's that we sort of answered but might be applicable to the group as a whole instead of responding to the question?
Yeah, I think, well, one was related to updating groundwater conditions or infrastructure and having wetlands and how those two water systems would interact, drinking water and wetlands. Maybe you can speak to that, and I think it would be understanding the hydrology and hydrogeology and a little bit more about the question, but can you speak to the groundwater and the surface water interaction when you're constructing a wetland and managing drinking water systems?
I could try.
I'll say Heather or
So if you are applying for a new groundwater use license application for your drinking water supply, if it's a well, you would definitely now you must figure out if there's a likely hydraulic connection to the wetland. So if you're doing a pumping test, you're probably going to need to put some stilling wells or some sort of monitoring in that wetland to make sure you're not drawing down. And you'll probably want to make sure there's a good clay layer. Hopefully your well's in a confined aquifer, and you can prove that you're not hydraulically connected to that wetland. Groundwater must consider environmental flow needs now for any aquifer that is connected to a stream.
And that's under the Water Sustainability Act.
Brand new, yep, 2016, a 180 change in my world.
And just a note, now wetlands are classified as a stream under that
Correct.
designation.
And that's based on the high water mark of that wetland. The limit of that wetland would be based on vegetation.
Vegetation and soil usually is how we delineate wetlands.
Yeah.
Okay. So a diversion from the regulatory and then the planning and infrastructure is educational opportunities. So maybe Carrie, you can speak to that on possible projects you've had that have had educational opportunities or related to grant funding. That was from Kobe West.
Okay, great. Educational opportunities in regards to wetlands, Mel?
Yeah, and bioengineering.
Yeah, I think there's great educational opportunities for school level all the way up to university programs. School level is really teaching about watershed health, again bringing it down to our water cycle, watershed health, and how wetlands actually interact with our watersheds on a groundwater and surface water level, and getting the kids excited about the plants and what wildlife uses those areas and how it's all integrated as a whole, and how that it can increase our climate resiliency. Constructed stormwater wetlands are really great. I mean, they've been around, the science has been around for a very long time, but there's new science coming out all the time. So even, research studies going on with how different microbes break down different contaminants is really interesting. And there's lots of opportunity there. And educational opportunities just as far as, natural systems and just even birding. And we have a lot of unique wetlands here in the Okanagan, and there's a lot of saline and alkaline wetlands that attract different migratory birds, some species at risk birds. So there's really great educational opportunities to visually see those rare migratory birds that only require unique habitats.
Maybe further to that with the bioengineering, we have done projects where it is a full day or 2-day workshop installation, and the people are learning how to install a bioengineering and the project's getting done. You have all sorts of labor available to do the hammering and the cutting and everything, and it's a great way for that mutually beneficial work to happen.
Right, and then also with bioengineering projects, you know, we can teach operators and park operators in order how to install these bioengineering systems. And like Mel said, do a 2-day workshop or a 1-day workshop, and you really get the idea once you get your hands on those stakes, how they're installed and how they interact with your site, and just create training opportunities for your operational crews as well.
There is one more question that came in. We've got 3 minutes left, so maybe you can follow up afterwards if it goes on a bit longer, but we'll give it a shot. Have you had any experience to compare the success of dormant unrooted stakes to planting live rooted stakes in bioengineering applications?
I don't have any personal experience in planting pre-rooted stakes. I know some colleagues that have done that. If you can pre-root your stakes, they do tend to do better. They are a bit trickier to install, as I understand it, because you don't want to break up those root systems. I find if I'm working with a crew that is a bit or hasn't installed stakes before, it's enough just to install the
Yeah.
unrooted stakes. Pre-rooted stakes does take a bit more finesse for install, I think. That's what I understand.
Thank you, Carrie, and thank you for that question. So yes, that wraps up the Q&A portion. And as a reminder, if you happen to have missed a part of this webinar or you want to hear Heather's or later on Drew's again, it will be on our YouTube channel. Just search Associated Engineering in YouTube. And if you still have questions, please email me and I'll find someone in whatever practice area it happens to be, and we'll get back to you on that. A reminder about our next session with Drew Layback, Tuesday, June 23rd at the same time, about unlocking the mystery of EFNs. So with the enactment of the WSA, decision makers must now consider EFNs when reviewing a new groundwater use license if you are hydraulically connected to a stream. And of course, they must consider EFNs for surface water use applications. Drew is a senior hydrologist that is widely recognized as an expert in developing the naturalized flow curves of streams that go into building and setting the EFNs, and he's worked with biologists that have set EFNs. So we're very lucky to have Drew out of his hip waders to share his knowledge with you folks, so I look forward to that. So once again, we'll be sending out a short feedback survey. So if you can please take a moment and fill that out, that'll help us for our next one. And in addition, just a reminder, these sessions do qualify for your continuing professional development hours. And so with the extra Q&A session extended for another 10 minutes, you can now put down 2 hours on your informal category. So thank you to Carrie, Heather, and Mel for making this webinar a success. And thanks for joining me, and we hope to see you next week. Bye.
Great, thanks everyone.
Thanks, everyone.
Thank you.